Hi, in this lesson, before we start implementing our portal system, I was thinking that it would be a good idea to discuss a little bit the differences between local space and world space, or should I say world location and relative location. Because we will use these terms a lot, in the coming videos, so you need to understand what these terms means. We will use a lot of those functions. And in order to make this very clear to you, so you can understand what that means, I'm gonna create a basic cube here, or rather a basic actor, so we can test with this. You don't need to follow along here. I want you to just look and understand what I'm doing here. So I'm gonna create a test folder. In here, I'm gonna create a blueprint class actor. I'm gonna call it BP test. Okay. I'm gonna open this up. We're gonna keep this simple. I'm gonna add a cube to it. And I'm also going to add to this cube something else. Let's see. I'm gonna add let's add either a cylinder or cone. I think a cone is good. I'm gonna drag it out like this. It doesn't really matter, but I'm gonna give it a color so we can differ between them easily. We can also give this another color. Let's see if I can find a red one or something like that. Let's see. Let's go with blue. Yeah, I think this is good. So I'm gonna drag these actors out. Okay. So this is the actor. Okay. I just dragged it out. And if you look at my right screen here, I have now selected the BP test actor. And when it comes to those terms, you will most likely work with, well, relative location or relative rotation in many cases. But in many cases, you will also use, well, world location. So really, if you look here, the world location is a location on the map in the world. In the actual world itself, as you can see here. I'm in the world now, and if I move this around, you can see that the y-axis is changing because I'm dragging this y-axis. And since this is the actor itself, I'm currently just changing the world location. If you look here, it says location. By default, you have these two here. If I select world, it says absolute location. This is really the world location. But if I select relative, it means the location relative to its parent. The parent can be either a component or it could be an actor. But this is really the main parent actor. This is the top actor that contains all other components. And therefore, whatever change I'm doing here is really world space. Okay, so if you look here, since I'm changing it at the world space like this, you can see that the relative location of this actor called BP test, it's currently having the exact same value as the world location. Because this is the, well, main parent actor in the world. There isn't really any relative location to this actor itself, because this is only existing in the world, as you can see. So since this actor exists in the world, both the absolute location and relative location are exactly the same. As you can see here, they are not really changing. Okay, so let's take a look at another example. If I just go here, You can see that we are having this cone here. If I just remind you and open this up, you can see that we are having the cube, and the cube is having a child called cone. So the cone is having really a relative location to the cube. So let's take a look what this means. If I select the actor, you can see the hierarchy here. This is the cube, and this is the cone. So I'm going to set relative location of 0, and this means it will have an exact same location as the cube. If you look at this, so this is really its location relative to that cube. The x is increased by 110. The y and z components are set to 0. If you set this to 0, it will have the exact same location as the cube. There you go. It's inside the cube now, so you can't really see it. I can also drag it out. There you go. So you can see that it says 110. So this is relative to its parent, okay? It means that if you count this x110 from the parent's location itself, you will get an x110. If I decrease it, you can see it changes. The same goes for the, well, y-axis here. So with respect to the parent, this is the location. So let's take a look at the values if we are talking about, if we change this to a world location or absolute location. This is the world. So look at this, we are getting totally different values. So what are these values really telling us? Well, this value here, relative, it's only relative to the cube, as you can see here. However, the cone's location in world space is relative to the world. Okay, we are talking about the world position. And the world position is really the same position that this default scene root is having. So let me just change this to world again. You can see that it says 14, 30, 11, 60, 210. What I'm going to do is first change back to relative. I'm going to set this all to 0. Okay? This makes understanding even easier. I'm going to tell you why. If this is all set to 0, I'm going to change this to world location again. You can see that I have 1320, 1150, 210. This is its location in world space. So what is it really referring to? Well, it's referring to the parent component. If you look at the hierarchy here, we are having this root component called default scene root component. If I click on that, you can see that its relative location to the world and its world location are exactly the same. Look, because I just discussed that before showing this to you. This is the root component, so it will have the same relative location and world location, okay? These are two exactly the same. Also, what I want you to see here is that if I change it to absolute location, look at the values here. These values are exactly the same for this cone here. 13, 20, 11, 50, 210. 13, 20, 11, 50, 210. So the world location of this cone here is exactly the same as its parent, the root parent, okay? This is the root parent. And if you want to know what this world location to this parent is, if I select this cube, well, if you look at the relative location to its parent, it says 0, but if I change this to world, it's still the same. Because this is also having a world location as the default scene root component. Okay? So really, when we talk about world location, we are talking about a location in the world. And if we are talking about a relative location, if you look at the cone here and the cube here, these are having relative locations with respect to the parent. So if you consider this, if I look at a cone here, I'm going to change this to relative location. It says 0, okay? And this is the relative location to the parent. However, if I set a starting point for the x to 100, now the relative location will affect what results you will see in the actual world location, because we start at 100. Okay, so if this shows 100 here, I change this to world location, you can see that it says 1420 here. If I change this to relative location now, if you look at the x, it says 1420. That's because I changed that relative location to 100, because we start at 100. If I change this to relative again and set this to 0, it will say 1320 instead, rather than 1420. So the important thing to understand here is that the world location, or should I say absolute location, is really in world space. It's a location on the map. And relative location is really with respect to its parent. Okay? So again, if I look at the cone here, it has a world location as the default scene root component here. It also has a relative location to its parent. Also, another thing I want to mention here is that you will notice things like if you program the location or rotation in blueprints, you can see that you can get the actor location of BP test. You can get its world location, for example. But that will really just refer to this component here, default scene root component. Okay, so if we get the world location of this, it will really just mean that we are getting the world location of this. And the same goes with the subcomponents here, the cube and cone. These are having the same world location as this default scene root component. All right, so the takeaway is that we have global space positions, that is in the world itself. You can see here, I'm moving it around, we are changing the world position here. And the relative is relative to its parent. This is important to understand because we will rotate components with respect to its parent also. It's not really that hard to understand, but we will rotate them, and I will also discuss that further, with you later on in the course, why we are doing that. But it is fairly easy to understand why. Because in certain scenarios, we will rotate an actor or an object to face a specific direction, and when doing so, the child components will need to rotate along with it, so they match the corresponding rotation of the world location, or should I say world rotation. But we will get more into that later on. So really, I just wanted to discuss this with you about relative location and parent location. So with that said, thanks for listening, and I see you in the next lecture.